today we are going to discuss about system of forces. System of forces. The coplanar forces, concurrent forces. Coplanar, which means all the forces are acting in the same plane. When all the forces are acting in the same plane, then that is called as coplanar forces, right? So concurrent forces which means same time at same point, right? When forces act at the same time and at the same point, then it is called as a concurrent forces, right? So concurrent, this is the example, the intersection point is same, right? All the forces acting at the same point or the intersection point is same, right? The collinear, which means the line of action of all the forces along the same line. See here, this is the point and line of action of this force and this force both are in the same line, right? So then this is called as collinear forces. Clear? And this is collinear, this is the point already we discussed. The force 1 and force 2 both are in the same line of action is same for this force 1 and this force 2. So that is called as the collinear force. So this is unlike parallel forces. Unlike parallel forces, coplanar, parallel forces. Coplanar already we discussed. Coplanar, which means all the forces are acting at the same point, right? See here, all the forces are acting at the same point, F1, F2, F3 and F4. So all these forces are acting at the same plane, and see, all the forces, all the four forces are parallel and the direction is also same. So that's why this is like parallel forces, whereas unlike parallel forces, which means the forces are parallel but the directions are opposite. See, F1 and F2 both are in the different opposite directions, and F3 and F4, right? See, so forces are parallel but in the opposite directions each. So that's why this is called as unlike parallel forces. So coplanar, unlike parallel forces, which means all the forces are acting at the same plane and parallel but in the opposite direction. That's why this is called as coplanar, unlike parallel forces. Coplanar, like parallel forces, which means all these four forces acting in the same plane and parallel and the direction is same, right? So concurrent, which means the intersection point is same. So coplanar concurrent, which means all these forces, say for example this is force 1, force 2, force 3, force 4 and this is force 5. So all these 5 forces are acting at the same plane and the intersection point is same for all these forces. So this is called as coplanar concurrent forces, right? So coplanar non-concurrent, which means all these forces, here 4 forces are there, right? So F1, F2, F3 and F4. So these all forces are acting at the same plane and the intersection point is different. So that's why this is called as non-concurrent forces. Clear? And the resultant forces, right? So if a number of forces are acting simultaneously on a particle, then it is possible to find out a single force which could produce the same effect as produced by all the given forces. Say for example, this is the system and the 10 kilonewton is acting left side and the 20 kilonewton is acting right side, both are in the opposite direction. Then the resultant, which is equal to 20 minus 10, which is equal to 10 Newton right side, right? So this 10 Newton produces the same effect as produced by this 20 Newton and this 10 Newton. Clear? Similarly, in this system, the 15 Newton and 13 Newton both are acting in the same direction, then resultant, which is equal to 30 plus 15, which is equal to 45 Newton, right? So this 45 Newton, which is called as a resultant force, produce the same effect as produced by this 13 Newton and this 15 Newton. Clear? Now parallelogram law of forces. If two forces acting simultaneously on a particle like B and Q, so P and Q both are two different forces, right? Two forces P and Q acting simultaneously on a particle, be represented by O, right? So in magnitude and direction by these two adjacent sides of the parallelogram, this is one side and this is one side, right? So the resultant may be represented in magnitude and direction denoted by R, right? So by the diagonal of this parallelogram, this is the diagonal of the parallelogram. Here force P, first force, and this is Q, right? So this is one side of parallelogram and this is another side of parallelogram. Then the resultant, which is the diagonal of the parallelogram, which passes through the point of intersection, right? And the angle between these two forces is called as alpha, right? The angle between the primary force and the resultant, which is called as theta, right? The angle between P and Q, the primary force and secondary force, which is called as alpha, and the angle between the primary force and the resultant called as theta, right? And this is the formula which we want. R resultant which is equal to root of P squared plus Q squared plus 2 PQ cos alpha. P, which is equal to primary force, and Q, which is equal to secondary force, right? Two forces P and Q, right? And R, which is equal to root of P squared plus Q squared plus 2 PQ cos alpha. Then we need to find out the angle of theta, I mean the resultant with respect to force 1, right? So tan theta, which is equal to opposite by adjacent, so opposite, which is equal to CD, divided by adjacent, which is equal to OD, right? So OD we can write in the form of OA plus AD, right? So OA, we know that P, and AD, which is equal to, AD which is equal to Q cos alpha, right? So that's why CD, which is equal to, we know that Q sin alpha. So CD Q sin alpha and OD, which is equal to P plus Q cos alpha, right? So this is the formula for finding out the theta. So theta, which is equal to tan inverse of so and so, right? And let us discuss a problem. It's a simple problem. Two forces of 100 Newton and 150 Newton are acting simultaneously at a point. So what is the resultant of these two forces if the angle between them is 45? So two forces and alpha is also given. So force 1, which is equal to 100 Newton, and force 2, which is equal to 150 Newton, right? Then alpha, which is equal to 45 degree. We know the formula R resultant, which is equal to root of P squared plus Q squared plus 2 PQ cos alpha. So substitute these two values and you can get the answer 231.76 Newton, or approximately 232 Newton, right? It's a very simple problem. Just substitute the value of F1 and F2 and alpha in this equation. So P, which means F1, and Q, which means F2, right? So substitute these two values and you will get the answer. It's a very simple problem, basic problem. Now let us discuss another problem. Two equal forces are acting at a point with an angle of 60 degree between them. If the resultant force is equal to 20 root 3 Newton, find the magnitude of each force. So two equal forces are acting, right? Two equal forces are acting. So F1, which is equal to F2. From this statement we understand that F1, which is equal to F2, right? So next one, the angle which is equal to 60 degree. So alpha, which is equal to 60 degree, right? If the resultant force is equal to 20 root 3, so R, which is equal to 20 root 3 given. So we know that the formula R, which is equal to root of F1 squared plus F2 squared plus 2 PQ cos alpha. Substitute the values, which is equal to root of F1 squared plus, so F1, which is equal to F2, so that's why I'll take F2, which is equal to F1 square plus 2 into F1 F2 cos 60 degree. So R, which is equal to 20 root 3, right? So square on both sides. So 20 root 3 squared, which is equal to f1 square plus f2 square plus 2 f1 f2 cos 60, which is equal to 0.5, right. So here, so f1 square plus f2 square plus 2 into f1 f2 0.5 into 2, which is equal to 1, right. So 1 f1 into f2, clear. Cos 60, which is equal to 0.5. So now f1 square plus f2 square, f1 square plus f2, which is equal to f1. So f1 square. So totally 3 f1 square, which is equal to 20 root 3 square, right. So 20 into root 3 square, which is equal to 1200, right. So f1 squared, which is equal to 1200 divided by 3, right. So which is equal to 400. So f1, which is equal to root of 400, which is 20 Newton, right. So f1, which is equal to f2, we know that, so which is equal to 20 Newton, clear. So this is the answer, 20 Newton, okay. So now another problem. Next problem, find the magnitude of two forces such that if they act at right angle, the resultant is 10 Newton, root 10 Newton, but if they act at 60 degree, the resultant is root 13 Newton, right. So find out the magnitude of two forces. We have to find F1 and F2, clear. So what are the data given? So resultant, which is equal to root 10 Newton when alpha, which is equal to 90 degree, and resultant, which is equal to root 13 Newton when alpha, which is equal to 60 degree. Now we know that resultant, which is equal to root of f1 squared plus f2 squared plus 2 f1 f2 cos alpha, right. So just to substitute the value, root 10, which is equal to root of f1 square plus f2 square plus 2 f1 f2 cos 90, right. Similarly, root 13, which is equal to root of f1 square plus f2 square plus 2 f1 f2 cos 60 degree, clear. Now cos 90, which is equal to 0, so root 10, which is equal to root of f1 square plus f2 squared, so which is equal to 10, it implies 10, which is equal to f1 squared plus f2 squared, right. So similarly, square root of both sides of this equation, then automatically 13, which is equal to f1 squared plus f2 squared plus f1 f2. Simplify this, substitute cos 60 value and simplify this, then we will get this equation. This is 1, this is 2. Now we know that substitute this f1 squared plus f2 squared in this equation, then 13, which is equal to 10 plus f1 f2. Now f1 f2, which is equal to 13 minus 10, which is equal to 3, right. So f1 f2, which is equal to 3. So one more equation we got, and this is third equation, right. Now we know that f1 plus f2 squared, we know that a plus b the whole square, right. So a squared plus b squared plus 2ab, right. So here we know that f1 squared plus f2 squared, which is equal to 10 plus 2 into f1 f2, which is equal to 3. So totally how much? 10 plus 6, 16. f1 plus f2 the whole square, which is equal to 16. Similarly, f1 minus f2 the whole squared, which is equal to F1 squared plus F2 squared minus 2 F1 F2. Clear? So, now what is the value? 10 minus 6, which is equal to 4. F1 minus F2 the whole square, right? Clear? Now, take a root for this F1 plus F2 squared, which is equal to 14, then F1 plus F2, which is equal to 4. For this equation, F1 minus F2, which is equal to 2, right? So, this is one equation and this is another equation, right? So, this is 4 and this is 5, right? So, now solve this 4 and 5. F1 plus F2, which is equal to 4, F1 minus F2, which is equal to 2, right? Now, solve this. So, 2 F1, which is equal to 6. So, F1, which is equal to 3, right? So, substitute this value here, substitute this value in this equation, right? So, F1 which is equal to 3. So, F1 minus F2 which is equal to 2, this is the equation 5, then substitute the value F1. So, F2 which is equal to F1 minus 2. So, F2 which is equal to 1, clear, 1 Newton. So, F1 which is F2 which is equal to 1 Newton and F1 which is equal to 3 Newton, right? F1 which is equal to 3 Newton and F2 which is equal to 1 Newton. So, thank you.